In this video, I will show you how to find the determinant of a matrix if it exists. Let's start with a 2 by 2 matrix. Here's the formula. So as you can see, AD minus BC, we're doing the down diagonal minus the up diagonal. Okay, that's all it is. AD minus BC. Down diagonal minus the up diagonal. Alright, so that's what we're going to do here. Oh, by the way, symbols. See how I have the original matrix A and it's got these brackets? But then here I'm saying the determinant of A, and now all of a sudden I have these straight bars that look like absolute value symbols. In the context of matrices, when you see these straight bars, it means determinant. It means do this process. So, see these straight bars? It automatically means that I am finding the determinant. So, I'm going to do the down diagonal minus the up diagonal. So, that's why I'm going to do 1/4 times negative 1/6, alright, that's the down diagonal, minus 2/3 times 1/3, that's the up diagonal. Okay, so let's see what happens. This is going to be negative 1/24, alright, you just multiply straight across, and that's minus 2/9. Now I just need like denominators. If I multiply 24 by 3, I'm going to get 72. So this is going to make negative 3 over 72. If I multiply 9 by 8, I'm going to get 72. So this is going to make minus 16 over 72. So negative 3 minus 16, that's negative 19 over 72. So this is the determinant. Alright, and again, number 5. It's going to be, hold on, that's too big, the down diagonal minus the up diagonal. So the down diagonal is 0 times 2.5. The up diagonal is negative 3 times 7. So this is going to be 0 plus 21. Okay, this is negative 21, but minus a negative is a positive. So the determinant will be 21. Take a look at number 6. The determinant is going to be the down diagonal minus the up diagonal. Okay, so the down diagonal is negative 3 times negative 6. The up diagonal is negative 2 times negative 9. So this is going to be 18 minus 18. So that's going to be 0. So the determinant is 0. Okay, now the directions for the next couple problems say find the determinant of the following matrix and determine if the matrix has an inverse. Okay? The matrix will have an inverse if two conditions are met. Number 1, it has to be a square matrix. Okay, must be square. And number 2, the determinant cannot equal 0. Alright, if it's going to have an inverse, it's got to be square, and the determinant cannot equal 0. So, look at number 7. Let's find the determinant first. So that's going to be the down diagonal minus the up diagonal. The down diagonal is 3 times 2, so that's going to be 6. The up diagonal, 0 times 1, so that's going to be 0. So that's going to be 6 minus 0, which is 6. So the determinant is equal to 6. And it does have an inverse. So I'm just going to say yes inverse. Because the determinant is not 0, and it is a square matrix. So this is the answer number 7, that we found the determinant, and yes, it has an inverse. Okay, look at number 8. The determinant is going to equal the down diagonal minus the up diagonal. The down diagonal is 4. The up diagonal is negative 3. 3 times negative 1, that's negative 3. So I'm going to put plus 3, all right, because it's the down diagonal minus negative 3. Minus negative is plus. So the determinant is 7, and I'm going to say yes inverse. It's square, and the determinant is not 0. So yes, there is an inverse. Okay, what about number 9? So first of all, the determinant is going to be the down diagonal, which is 4, minus the up diagonal, which is negative 12. So the determinant is going to be 4 plus 12. So the determinant is going to be 16. So the determinant is 16, and I'm going to say yes inverse, because it is a square matrix and the determinant is not equal to 0. So yes, there is an inverse. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.